Thanks for having us, Jason. Thanks for the invitation and the opportunity. I shared before we started that crazy story that I remember about. Jason and I used to work together at the same company for many years, and not in different departments. So we didn't have much face-to-face time. And it wasn't until after I had left that engagement, after 7 years of working quote unquote closely with him, that I had my first conversation with him. And that happened to be in Washington, DC, in the Capitol building, waiting for a tour. We just so happened to be, I don't know, like 3 and 4 in the line. So it was, if there's any coincidences to be had, that definitely qualifies. So again, thank you for everybody for joining us. Here's what we're going to be talking about: introduction to Kalderos. Then Andy Wood, one of our engineers, is going to talk about the React app and the front end of the system that we're going to be describing. And then Mike Tai, who's our VP of Technology, is going to talk about the microservices that sit behind that. And then Jose is going to put a bow on all of that and talk about the DevOps and Azure microservices and such, kind of the infrastructure that makes this all possible in Azure. And then I will talk about some things that used to be concerns maybe for the infrastructure and network engineers. And I think as development teams, we'd always considered them, and they were always fun to plan, but they were really hellacious to implement. And so we'll take a peek and see how easy that is today, so that you still get the excitement of planning for it, but you don't have to do all of the legwork. So we kind of talked about this already, but one more point: this is an interactive thing. This is not a soliloquy. We hope if you have questions, just pop them in the chat or raise your hand, and we'll take the presentation off the rails and get your questions answered. So Kalderos, we are a company that, as you can see, we deliver a unifying technology that solves the problems facing the U.S. healthcare system, and with a primary focus on pharma, and so drugs and prescriptions. And the idea is that we work with healthcare providers, so the people who are dispensing drugs, manufacturers who are making the drugs, and payers who are paying a vast and complex web of discounts and rebates for those drugs. And we provide transparency so that everyone who's participating in that conversation can see what's happening. So we're kind of anti-Wizard of Oz. We're showing you what's going on behind the curtain. And that the idea there is that a lot of what I'll call fake costs, historic fake costs, because there have been curtains, are go away, because everybody can see what the detail related to the conversation about price is. We're in our 6th year as a startup. Our headquarters is in Chicago, and we have a satellite office in Brookfield, which is right across the street from Thomson Reuters, now Refinitiv. And we actually have hired somebody from there. That's another interesting story. We cast a wide net for one of our first business analyst hires, and it was a national search, and it ended up that we found our first candidate right across the parking lot from us in Brookfield, Wisconsin. We are a venture-backed firm, so we've done 2 rounds, Series A with Mercado Partners, who are like family to us, a company in Utah that we found and we love, and then of course Bain Capital, which is a well-known name in that space, and we love that they're on board as well. The themes of how we work as a company is that we're agile. Obviously, we hew to agile principles. We're not dogmatic, so we take the best of what agile has to offer and run our product teams that way, all of our development efforts that way. We're flat, so the idea is that you're never, no matter what level of the company that you're at hierarchically, you're never more than 2 steps away from the CEO. And we think that's super important, because the transparency, again, and the ability to talk about what's going on in the company and to express your opinions and voice your ideas is super important. We started as a BizSpark company, which is a program that Microsoft has, where you essentially get a bunch of free Azure until you become a 3-year-old company or a $1 million revenue company. And that's the reason that we're in Azure. We had such a great experience with those first 3 years and that first $1 million. And if you've spent time, I'm sure there are people who have spent time in Azure, you know what it's like. You open your browser, you go to the portal, and there's 3 more tools for you to use, three more opportunities for you to build new things. And from a technology perspective, we do web and API. You'll see that today. We do data engineering as well, and data science, where data is critical to what we do. It's probably the most important thing, with the root of all of that being a prescription claim record. And then obviously we are heavily involved in security, and then tech and DevOps as that infrastructure management. And just a note on security, we value security probably more than performance. And I think we're able to mix those two pretty well in Azure, and bring some third-party tools to bear on that problem also.
Great, thanks, Dave.
Yep.
So this is Mike speaking. So I'm going to just give an overview of the app, what we're showing you today. So we're starting from the web front end, which Andy will show a little bit more detail. That's the React part. And then when it's my turn, I'm going to go over how we use the different capabilities of API, Azure Function, and other Azure capabilities later. So I'll turn it over to you, Andy.
Cool, thank you. And all right, so the way we utilize this, basically any detailed process that we use in our system, we use a tool called Redux, which is a centralized state manager. If you're not familiar, basically we can save data in one part of our app and access it from any other point. So it's a really useful tool. And that's what this functionality is hooking onto. What we're going to demo today is something we created this last sprint. Basically, we have some customers that have the need to potentially download up to like 200,000 records at one time. And while like normal browsers would probably would cancel out at that time, there's different static requests timeouts. We basically developed this tool that will just continue pinging the API until we get that successful response, and then we'll deliver the data to the customer. So I'll go ahead and share my screen. All right, is this big enough? Or do I need to blow it up?
That's better, Andy.
Okay. All right, so first thing, when we go to download a record, this is the tool that we recently developed. Let's find one that's a little bit larger. Clicking this functionality with its wired in Redux, I can navigate to other parts of the app. It's going to continue working in the background, regardless of if that component's mounted or not, and then we're going to get a successful download. Basically, what's happening on the code side is we've got a couple watchers. We're using Redux Saga here, which is another tool, not inherently different than Redux, just different syntax. But basically, what's happening is we have some watcher functions. So anytime this constant is like true, it's going to do what we tell it to, essentially, right? So for this instance, we've created a download, and that would be initiated right here. One sec. All right, create download. So we create a download. We show the download, which is what that little spinning guy comes up. And then we start a polling process. So during that polling, every 5 seconds, right? Like while it's true, it's going to, that watcher is going to get kicked off, and it's going to begin that polling process. So while it's there, we snag some variables from other parts of the app using Redux. And then we're just retrieving that report. So we're going to hit that API, pass in the URL, and then every 5 seconds, based on a delay, which is listed here, it's gonna go until we get that successful response. And then future iterations of this, we're gonna add some error catching, because right now, regardless if we get a 404 or not, it's going to continue running. So future reference, we'll build out like a 200 while it's in process, and just not have data. But once that download's done, we actually initiate the download, we stop the polling process, and then we call it a day, we pack it up. So that initiate download is just telling the URL, creating an object on it, and then manually clicking it for the user. So again, navigating throughout the app, regardless of where they are, they're going to have a smooth experience there. And yeah, that's all for the front end. Do we have any questions before I pass it off? If someone wants to zoom in.
Okay, thanks, Andy.
Cool.
I can share my screen now then, Andy. And then doesn't have questions?
Yeah. How do I kill it?
I think you killed it.
Oh, cool.
Okay. What was showing was the workflow of the web. When you first click download, it requests it from the API. And then because we wanted to do asynchronously, we kick off a thread to actually do the work. And we immediately return the success back to the caller. So the front end will then start showing the spinner, as Andy was showing. And then, as Andy said, periodically, it's going to ask the API to see if it's ready. And if the API says it's not ready, then it returns a 404, and it'll keep polling until it is ready. And so once this thread is kicked off, the thread will now go retrieve the data from the database. And because of the amount of data, we also do pagination when we retrieve the data. And so once we get all the data loaded up, we generate the Excel file using a npm package or a package EPP plus, and then we upload the file to storage. We update the database to say it's ready, and then the next time the front end comes and asks for the file, we said, "Oh yeah, it's ready. We're going to give you the file from storage," and then the status. So that's kind of like the general overview I'm going to show, and then just a couple of notes. I showed back here that we have our C# API and Azure Functions, and why did we create an Azure function and a C# service versus just putting everything in the service? One of the main points is we wanted to abstract the database access and functionality from our application code. So this is kind of a generic reporting service that the Azure function provides. So if we have our other applications that need reporting services, they can just call that Azure function, and they don't have to add that same code in their API. And then when we started looking at the asynchronous operations, we looked at a couple alternatives and versus doing a thread. One of them was event hubs. So we use event hubs a lot, being able to post a message to, and then waiting for a trigger to run off of. We already had the code built out to generate the Excel file in our API, and we could have moved it into the Azure Functions, not that big of a deal, but I think overall we're just like, if we add another event hub, it's just another item in our infrastructure to manage. It was easier just to do it in the thread. And then a couple issues that came up during implementation, which I'll show, is that because you're kicking off the asynchronous part in a thread, the dependency injection scope doesn't work. And so you have to explicitly instantiate the objects that you need. And then even though the thread is running asynchronously, if it's running for 5 minutes or something, we're fine from the web front end because it's just going to keep polling. When the thread is calling the Azure function to retrieve the data, the retrieval of the data itself could take a while. So we didn't want any timeouts between the thread and the Azure function. So that's why we did pagination in here to make sure it doesn't time out while we were processing that data. And then I'm going to talk a little bit about GitHub for the local environment to create the Azure functions. So real quick, just so it's easy to see, the database has a simple tracking status of whenever we create a file for download, we generate a GUID for it, and then we track status against that. It updates status if someone cancels it, or when it's finally downloaded, we just basically update a row in the table representing that download. And then we actually host the functions in Azure portal, but I'm going to show you running it on my local machine. So I'm going to turn it over to the demo part. So showing, if you click the download, I set some breakpoints. And so the first thing that gets hit is our C# API. And I'll make this a little bigger. And so this is retrieving the download file that the front end is asking for. And like I said, we create a GUID to represent this particular download. Let's see, I'm not used to this screen being so small for the step forward. Click one of these guys. Okay. So here's updating the database. Like I said, it's the first step is it says the file's being created. So that's just updating the database. And then this is where we kick off the thread to actually do the work. And then you'll see once the thread is kicked off, it just returns back to the front end, the GUID. And that's how the front end keeps track of this download when it asks for it later. So if I run, now you'll see this is actually running within the thread now. And the front end got his response back. So it, maybe it didn't get it back yet. So this is our API. It's saying, now I'm going to update the status that says the file creation is in process. And here's where we're doing the pagination, where we're actually going to go call the Azure function to download the actual report data. And one of the first things that we check in here is, did the user cancel the request? So if we're paginating over hundreds of thousands of records, if a user clicks cancel, we'll update the status in the database that the file was canceled by the user. And then if that happens, then it'll just stop paginating. This is what I was mentioning about the scope of when we want to update, when we want to query the database, because this is running inside a thread, we have to explicitly say create this scope to run in. And so this is where we're checking the database, we're checking for the status. And if all is good, this get report data view is the one that's actually going to go call the Azure function. So if I run to there and I step over it, so now you see a breakpoint inside. This is inside my Azure function. So with Azure functions, you can run them locally. You can create them locally, or you can create them in the portal, which I'll show you after I show this part. And so the nice part about running it locally is you can set these breakpoints, and you can do a lot of stuff like looking at the variables and stuff like that. And the way that we do our development is we build it locally, and then Azure DevOps to publish it into the portal. What I was showing in this picture of it actually being deployed inside the portal. And so we do our development locally, we save the code in GitHub, and then you run the DevOps process. So in here, it's running inside the portal, or inside the Visual Studio Code, and it's looking for a particular type of trigger. And so this particular case is, it's either get or post trigger. So this will present itself a URL that you can call when you first start it. You can see if you want to call it, this is the URL that gets generated, and it knows how to handle gets and posts. And so this particular request is by the API asking for it to generate or to return the data that it can then use to generate the Excel. And a couple of nice things about the Azure functions is that if you do these logging, you can see the results down here. It's kind of like a console window. And so right now, let's see where my next logging. I'm going to run it. So right now, I can put in logging and saying, hey, this function's finished, and you can see it here. And the other nice thing is when you run it, let that run. When you run it inside the Azure portal, you can see these log results as well. So if you have a live site going and you're like, hey, I want to see what's going on, you can actually go into the Azure portal and see this same log happening. So what we do is we log like the queries that are being executed. So if somebody's like, hey, I'm not getting the right results or something, we can actually see what queries that we're executing when a user is trying to hit it. Okay, I think something timed out in here. So over here, when it's, let me trigger it again. I think I held it up too long. Okay, trigger it again. Okay, again, it's going to create another GUID. It's going to kick off the thread. It's going to call the Azure function, and then Azure function should be here. Breakpoint set. I can execute it just like, okay, so now it's back inside the API in the thread, and it got the message back in JSON. And so now that it has the message back, it's just going to create the Excel file. And once it creates the Excel file, it will then, let's see at the very end here, a lot of Excel manipulation going on. Right here, it will then upload that file to Azure Blob Storage. And so it identifies it based on the GUID that's created for it. And you can see here it's uploading the file, and then it's updating the status. It says it's file ready for download. And so later, if when the front end calls retrieve the file, the first thing it does is says, hey, I'm going to see if the file. So, if it's in process, I'm going to return null. If there was some kind of error, it's going to throw an exception. Otherwise, it's going to come here. It's going to retrieve that same file from Azure storage using that same GUID. It's going to download it from the stream, update the fact that the user and returns the stream back to the front end. So that's kind of just showing that round trip of, initiating it with API, kicking off the thread, calling the Azure function to get the generating the Excel file, uploading it later when the front end asks for the file, it pulls down the file from storage and returns it back to the front end. So next I'm going to show creating a function app through the Azure portal, but does anybody have any questions or comments about what I've showed so far? Okay. So like I mentioned, you can create your function apps to run either locally or on the portal. And so I'm just going to create a fake one here. And okay, so when you create a function app, you can actually select which runtime you want to run it in. So it doesn't have to be .NET. It can be Java or Node or other languages as well. So that could be another reason you'd want to put some code in the function app, is if you had a different team potentially working on, in our example, the reporting code. If for some reason that team was in Python or something, then you could develop it in any language that you want. And I'm going to create this now. Give it a second here. And so you'll see, so you create the function app, and the function app is kind of the container for the different functions you want to put in there. And so there's commonalities between the functions, such as configuration values or where the logging happens and stuff like that. So think of this as like the containing application. You want to actually create your functions, they run within there. One of the things that you can do is when you create the functions, you want to put some security around it, that you can say that the function is protected by a key, which is basically a query string parameter that you have to pass in. And so you could say all the functions within this function app share the same master key, or you could create a key specific to each function. So, out of convenience and really no real difference in security for us is if we do have like 3 functions in there that we just use one single master key, it's not really worth creating separate ones for each function. So I think this is almost done. So when you do your security within there, where's the picture yet? If you did have 3 functions in there, part of the security is that secret key that you pass on the query string, which is the keys that you manage through these app keys. And so, if you wanted to put in your own custom security as well, you could, but that's kind of the default auto to have that security. Okay, so now I'm going to go to the resource. It's finished. So now I have empty where I can create my functions and some default ones that you can use. So the master, these keys, if you say I'm going to use them, these keys can access all the functions within your function app. And you could either use the default ones or you can create your own key. Something that we found out is that we create multiple instances for all of our app services and function apps we create for load balancing and for high availability purposes. So when we first did it, we're like, oh, wait, there's different keys for each function app we created, and our C# API that's calling this needs to know which key to use. And so we couldn't use like the default ones because they're different between each instance of a function app that you create. And so we actually just created a new host key called like Kalderos key or something. And for these default ones, you can't change the value, but if you create your own, you could set your own value. So if I go into a function and I say, I want to go add a new one. And this is where development portal is kind of the default, which I'll show. But what we actually do is we use Visual Studio Code to create it. And if you select that option, basically when you select this option, it's just giving you instructions of how to do it. So it's saying, install Visual Studio Code locally, install Node.js, install this package, and then do this extension for Visual Studio Code. So if you follow these instructions, it's a little confusing because it's kind of all over the place. But once you get it going, you could see in here, in Visual Studio Code, you'll get this new Azure icon here. And then when you come in here, if you're starting from like a brand new folder, like these little icons up here, it says create a new project, and it knows it's a function app. And then if you want to create a new function, you create this one. So once you get that going, and I think Visual Studio Code will also ask you if you're doing C# or something, if you want the C# extension, that then you can just kick off the debug process and run it by running F5. Okay, so I'm going to go back here and create it again. Okay, I'm going to say development portal. So when you create the function, you can do trigger, which I showed, which basically means it's going to have a URL that to, or you can do like a timer trigger, which basically means this will run on a schedule, just like a cron job, where you can specify the schedule of when it. And then it has a bunch of other ones where it could say up or do that. So the nice part is once you create it, it creates that shell for you. And then the code that you write in there, in my example, is just standard C# code. So I'm going to say create a HTTP trigger. And I think there's asking for a name down here. And then this is where I'm saying the authorization level. You could say use a special key just for this function, or anonymous, or use the admin key. So I'm going to create the trigger. And so, you might want to, like, if you're just playing around or something, I would say just create it in the portal versus doing the whole Visual Studio Code thing. Also, if you're like, hey, when do I do something that's, permanently that I might want to do in the portal? If it's something very simple where you don't envision doing a lot of coding, that, maybe you're just using it for the timer trigger functionality, you may say, like, you know what, I'm just going to create it in the portal. I'm not going to go create it in Visual Studio Code and do the DevOps process. So you go into this code and test, and then you'll see it'll bring up the shell. So basically, here's the entry point for this HTTP trigger. And then if you want to test running it in the portal, you can say to test run. And here you can specify, posting to this function. And if you run, you will see that the code ran. And you can see, like, that's the result of this function right here, is to say that the trigger function executed successfully. You could also say, I want to get the function URL. And here again, the key is always indicated, whether you want the function key or the master key. So I can copy this, and I can go into like Postman or Insomnia and do the same thing. So you see the key is in here. This is the function key. So if I send it, you can see the log here just got triggered. And then you could see the response here. So if you're doing some complex programming and you want to do it through the portal, that's one way, is, you just save it in your Insomnia, Postman, whatever, and then you can just keep triggering it and making changes here and see those changes happen. One other thing I want to point out is that, what's this guy? I'm going to copy in a snippet of code that I saved. Okay, so I'm going to put in some. This function is just calculating numerator by the denominator. So you could say, I expect these values on the query string, and then it'll log it, and then it'll do the calculation and show the results of the calculation. So if I save this and then run, like, I'm not specifying, I'm just going to run it. And then you can see it blew up because it's tried to do a divide by 0 here. And so this is just showing, if you wanted to pass parameters, you have this input method. And so you can either add it as headers or the body or the query string parameter, depending on how you want to do it. So if I run it again, you can see the result is 2. So one of the things is I put in the error handling in here for that catch case where the code blew up. And so you see these log information, log error, that shows up in the console window, which I just showed, but it also goes into App Insights, which is a nice feature of Azure. And so if I go back into this function app and I say I want to go into App Insights, I click in here. And this is basically, for people who haven't used App Insights, is basically like a log place. So if I just do transaction search and I say, there's log information. And then you can see here the divide by 0 showed up in here. So what we do is we log the information into App Insights. And then one of the nice things that you can do is that then you can set up alerts based on it. So if you said like, hey, I should never get an exception or a failure, like if I look at the failures, I can see the divide by 0 show up here. One of the things I can do is I can set up an alert, and I can say create a new rule, add a condition. I could create something in the log that says if I had an error greater than 3 times or something, I'm just going to say something here in whatever period, 5 minutes, 5 times, that okay. Let's see. All right, I skipped this part. So basically, you can build your queries here, and then so you don't have to see me struggle on the syntax right now. Once you create this basically like what's triggering this alert, then you could say, what actions do I take? And so what we do is we send a message to PagerDuty, which will notify people that an error has occurred. And then you can put whatever information you want on here. So it's kind of nice that every function app that you create, you have this capability. And then one of the things that we did is instead of having every function app saved to its own app insights and creating an alert on each one, we have them all logged to the same app insights, and then we can create one alert that handles all of our apps. So in the actual configuration, you can see in here, there's the app insights instrumentation key, which indicates which app insights instance you go. And so in Azure Portal, this is basically like your web config or your local settings that you would add the information here. So that's it for my part. Does anybody have any questions? You have different app insights for dev test. Yeah. So the question in the chat is, do we have different app insights for dev test stage prod? We definitely do. And like I mentioned, we with Jose, we got a little smarter. Like we used to have our separate app insights for each application, but per environment, we do point all of the things in one environment to the one app insights instance. Okay, with that, I will turn it over to Jose.
Hello, and as I get my screen shared, I'll just a comment on the App Insights thing. App Insights instances are free. You're paying for the storage, so if you need to cut them up as granular as you want, it doesn't cost you anything. So cutting them up too much has some drawbacks, but I just wanted to put that out there. So I'm gonna talk about sort of how the code goes from we use GitHub and into Azure. So that sort of DevOps process. DevOps is a little bit of a buzzy word in the industry. It's more of a concept than like one thing, but I won't go too much into there. I'll start off by introducing Azure DevOps. It kind of takes a bunch of different tools out there like Jira, Jenkins, Chef, JFrog Artifactory, things like that, and melds it into one tool, all hosted by Microsoft. Admittedly, although we are a mostly Microsoft shop, we actually only use the pipeline functionality and the artifact functionality within DevOps. And I'll kind of talk about that in a second as to why we do it that way. But about, I don't know, like if you go back in .NET development, maybe 10 years, the industry standard was probably TFS, Team Foundation Services, or Server, I should say. As more and more companies move to the cloud, that kind of split off into two different ventures for Microsoft. It was a server version where companies hosted them themselves or paid someone to host it. And then there was a cloud version, which was originally called VSTS, which I think was Visual Studio Team Services. And then around 2008, they kind of melted into one, right? Now it's Azure DevOps, which is cool because now you can self-host a server as opposed to having two different options where hybrid wasn't really an option for you. But the cool thing for us is since it is hosted and it is super flexible, there's a lot of different integration points. So while TFS was the industry standard for probably code repositories, we actually don't even use Azure DevOps for code repositories. We use GitHub, and Microsoft owns GitHub now, so the integration is pretty seamless. And then for the rest of this, I'm gonna go into our space and kind of talk at a high level about like our strategy and how we go about setting up a pipeline. And I'll talk about pipelines last because there is a lot to consider before you actually get into building code and deploying code. The first thing I'll talk about is our service connections. It's really the authentication piece into Azure DevOps. These are the three most common products that our pipelines integrate with. That's Azure, GitHub, and Sonar. And it's interesting because they're all kind of different in how you set up the service connection. I won't click into the Azure one because some sensitive information if I click here, you're going to see some sensitive info, so I won't. But this is scoped to if you're familiar with Azure, this is scoped to it can be scoped to the subscription and or the resource group level. So it is sort of our best practices that we scope it as to the lowest level as possible, right? So we don't want to create a service connection that can let a pipeline delete everything in a subscription. So we try and scope it to the resource group level. You can't really get any more granular than that. So that's something to consider when you're planning out resource groups in your Azure deployment. The other thing that you can do in these service connections is limit which pipelines have access to them. Projects can be broad, and particularly when you're creating them, you don't really understand the scope of your project. So it's really good at the beginning to get into the habit of taking these service connections and making sure you know which pipelines and who can have access and who does have access to those. I'll go into the GitHub one and I'll kind of show you one of these in real time. And it's using, you'll see here, it's using OAuth. So I kind of like this approach. There's a lot of different service connections you can create. I'll show you in a second. But I kind of like this approach because it's generating a token. It's not tied to an individual user, and you don't have to manage a password after I sort of authenticate. There are other ones like Sonar where you're just setting a password and you kind of forget about it, and you have to have a manual process into resetting keys and things like that, which is just not something that I like to do. So I really appreciate the integration that GitHub offers. Now, the thing about OAuth is you're gonna have to go to GitHub to manage how long that key has access. You can't do it anywhere in DevOps. So sometimes these keys expire, and the errors that you see aren't super intuitive. So you might have to do some digging if your code isn't getting pulled into your pipeline. So just want to give you a quick demo on how this stuff works. It's really easy. If I didn't already do this earlier, it would have prompted me for my GitHub credentials. But as you can see, now it generated a token. It refreshed the token. So I'm probably good for about a year with this service connection, unless in GitHub you have something else defined or defined in a different way. And then the last one that we use a lot is Sonar. So we use Sonar Cube to do some sort of like code quality checks. This is probably my least favorite of the three, is in terms of the way that they handle this. It's really simple, right? You pass it through your Sonar Cube URL and you give it the token after generating it in Sonar Cube. And this isn't great because while for us, best practices, we generate tokens by project. If someone who's setting this up isn't familiar with your best practices, they can actually generate a token for their user account. And if that account gets disabled, then your Sonar Cube tests and the service connection will break. So it's in your best interest to make sure that you have a process for these sorts of basic authentication. And if we take a step back and we look at all the different service connections, this isn't the entire list, by the way. Like these are what comes out of the box, but you can add more if you do have like something that's a little bit different, and maybe not like one of the like leaders or whatever in these service connection types. And then there's also the sort of generic, if it's a completely custom thing that your company built in-house, you can add a generic thing and it's username, password. All of it is optional because it gets super flexible as to how you apply these in the pipelines. The next thing to consider is like what triggers a pipeline, right? Or what are the considerations you have when you're first starting with a pipeline? We're not even talking about steps or anything yet. The first thing you're gonna have to do is take a look at your build agent image. As you can see from this dropdown, there's really three main types of build images. There's a Mac OS, which I personally have never used, but I assume if you're doing like iOS development, it may be useful. There may be certain commands that run on here. Ubuntu, which is a Linux-based server. We use this about half the time, or maybe 30% of the time. A lot of our front end stuff is npm, and it just plays nicer. And then Windows. So I prefer using a Windows machine for this stuff. You get PowerShell installed out of the box, which is good. So you're not messing with like Bash or command prompt. So I'm a fan of Windows. Not all the developers on our team are, but that's what I prefer. And then I guess this is where I'll sort of like take a step back and talk about like an important decision we made as an organization that Dave talked about, right? We want to be cloud first. If it were, we could also take the Azure DevOps tool and run it on the server in, I don't know, we could even host it in the cloud, or we can run it in the server room in our office, but it wouldn't allow us the flexibility of just adding agents and agent VM versions on the fly like we do very often, right? Like if we're doing like a proof of concept for something, we can quickly spin up a build agent running Linux or running Windows 2009 or 2016. When you're hosting that stuff, you kind of have to have that infrastructure in place, and it's very easy for us. Like I think at the moment we have maybe 5 or 6 different agents we can have running parallel, and it doesn't matter which version which VM version we're running. I quickly want to just give you, I'm going to come back to this, but I'm going to quickly just show you like the preloaded software that comes on an image, right? So it's like you have a lot of the like very basic, like very popular tools, right? So like something like Chocolatey, right? This is a package manager. You could just spin up a virtual machine, add a command prompt task, and then just download a bunch of dependencies on the fly without much, without having to wait for Chocolatey to install itself or any of these other things. So I'm just going to scroll through here so you can get an idea. There's a lot of stuff on there. It's pretty typical of what you find on like a developer machine. I'll take a stop right here and show you these web drivers that are installed, right? You'll notice it says Selenium here. If you're doing automated testing, this is very helpful. Like we don't have to go through installing Selenium and drivers. We do have to make sure they're on the latest and greatest, right? Because these images do get updated. So if you're using a testing software and it's on an older version of Chrome, it's possible that you have some breaks with your test cases. And I think that's the last thing that I would note on there, but you can see Python's on there and a bunch of other stuff. So you get a lot when you take the hosted approach versus if you're trying to host it yourself. I will say one negative is, and I'm not going to keep scrolling. One negative is like we have to go through and install some of the things that aren't included on the build agent every single time we build. So it can result in long build times. There's some things that we installed every single time that I wish were just on the machine, and it would save us minutes in our build. It hasn't been too much of a concern for us, or I mean, it's been a concern, but it hasn't held us up too much when it comes to like getting code out quickly. But in the future, there may be scenarios where we have a hosted agent somewhere just to speed things up when necessary. A couple other things that are important, but I won't dive into too much in this demo. Right. So this is variables are very useful. Not very. I mean, they're useful in all aspects of building. Of pipelines, both build and release. But they're mostly used to configure stages in your release pipeline. So if you want to, change a database connection string or something like that. Obviously, if you're writing to prod versus dev, you're going to be connected to different databases. This is where you would define that stuff. And then, sort of look back to your tasks. Your tasks are going to point to these variables. And all they are, like, and again, I kind of want to like demystify some of the DevOps stuff. All they are environment variables on your virtual machine, right? So if you were to open up a command prompt window and do the command, losing it off the top of my head, but if you do the command that prints all your environment variables, that's all it's doing here is it's sort of creating the different stages, or it's creating 3 different environments for you and scoping your release to that environment, depending on what stage it's in. A very important part here is our triggers, right? So this is where you define like what's gonna cause my code to or this pipeline to start. In this case, we're talking about a build pipeline, so build code. And in other cases, talking about releasing to Azure, so taking an artifact and pushing it into Azure. You can add as many branches as you want to. At Kalderos, we don't do that a ton. Like a lot of our code, if you check it into the main branch, it's going to get pushed to the development branch, and we don't alter our branch filters very often. But you can have at it, right? Like you could add 10 different branches here, and I've seen it work pretty successfully. Someone could say, hey, I'm going to work in this branch all week. I'm going to go and add that to the so that it builds every time and it's always in development. I've seen this mostly used if there aren't a ton of people collaborating on the same project, but it's something that's possible. I want to make you aware of that. The other thing that we do here, which is outside of the scope, I think a little bit, but are scheduled builds. So you could put together a pipeline that does like an automated task, right? You could one example could be like running tests out of band. So maybe your tests take a really long time and they don't need to be run every single time someone checks code into master. You could schedule a build to run tests every day. And then maybe at the end of the day, it'll run it, and it's in a separate pipeline even. You'll run it in a separate pipeline and then maybe send an alert if something fails, and then someone can go check it in before it's pushed off to the testers overnight or something to that effect. And I think the other important thing is history. I don't have one. I'm sorry, I don't have one here. I can't really show you other ones, but that's a limitation, I'd say, of using this like UI approach a little bit, is that yes, you do have like version control for your pipelines, but it's not necessarily stored in code like in a repository. You have to come here to take a look. As opposed if you were to try to do this in a YAML file, that could be stored in GitHub, and source control is a little easier, but our pipelines don't change very often. So it's easier for us to take this approach, and everyone sort of can visually see what tasks are there. This is a real world pipeline, so I kind of want to. Yeah.
Somebody asked the question.
Sorry.
What strategy do you use for branching? Do you use development master main, or do you use feature branches?
I would say that I think Mike would be a better person to answer that question, Mike.
Yeah, I mean, I think we do both. Basically, when you're doing your own development, you check it in. It doesn't trigger the build, but then if you do the feature branch or the master branch, then it does kick off that CI/CD, like Andy mentioned. So,
yeah. And I'm gonna just go through a build pipeline real quickly, give you the high level of like how most of our build pipelines work, and some of this I already alluded to, but so we have this task here. We're using .NET Core 5. I don't think that's LTS, and because it's not the sort of the latest supported version in a lot of ways, right? Like when we deploy like web apps, there's some features that aren't enabled for us because we're on sort of the latest and greatest, but it isn't the latest fully supported version. There's some limitations. One of the limitations is we have to sort of tell the build agent which version to use, because when it goes to use the latest, it's not thinking that 5.0 is. So that's a little quirk that us sort of staying on the cutting edge made us have to add an extra task, which for us isn't the worst thing because we kind of like being on the latest and greatest. I'm gonna skip over these because this is just a little bit of us doing some things internally, but I can show you I guess I'll go through them to show you kind of what's possible, right? So again, think of this thing running locally on your machine. We're just executing a basic curl command, and if you go to the actual agent here, you'll see that was returned. If you go to, this was our most recent run here, it shows the IP address. I feel okay sharing this because if you go to because these are spun up on the fly, this IP address is going to be different every single time a build is executed. So this isn't, this IP address is owned by Microsoft, but doesn't really have a ton of meaning. I'll skip over these. Like I said, we're a .NET house. So we're doing, some of these restores that we do are examples of things that I wish we could just have on our machine, right? So we have dependencies, we have dependencies that are in our project file, and they're restored every time this is executed. I wish we could just have those because our dependencies don't change very often, and I wish we could have a pipeline that didn't do that. That didn't have to restore every single time that the build was run. But again, that's sort of like the differences between a hosted and a not hosted approach. Again, we test every single run, and then we publish those tests, and the tests are also defined in our project files. I won't show you this, but because it's tightly integrated with different aspects, like if you were to go into test plans into this project, which is a real project that we have, there's a centralized place for all of your different, like every single test that was run. It's just a running list, so you can kind of see like if there's sort of drift away, right, in your code. If we, a month ago you were passing 80%, and now you're passing 70 or less than that. So it's kind of cool because it's tightly integrated with Microsoft. These sort of out of the box stuff, like you get, like we don't use it a ton, you get it. It's cool every quarter when we're doing like a retrospective on code quality and stuff like that. You have this tool here. Sonar Cube does a similar thing for us, but I don't know. It's like an added benefit that doesn't take a long time to set up, but it gives you some cool features. Also visually, it's really nice. Sonar Cube is again our code quality tool. So in theory, if there's like a vulnerability in something that we're shipping, it'll let us know, and we have the ability to like stop a build in that case if that happens. I'm not certain that this pipeline has that enabled at the moment, but it's something we can do sort of at any point. This is like an example of just like if you were doing this locally on your machine, you at some point you'd copy files around, right? That's what we're doing here. I mentioned earlier that there are variables that you can define here. There are also variables that come out of the box with Azure DevOps, right? Every single time there's a VM, a build is triggered, you're gonna have a list of places you can stage code, or you can stage whatever that's relative to sort of like where you are in the build server.
Jose, there's a question. What's your approach for creating build version numbers?
For creating build version numbers, I think that that's another question that I can't really answer. It's something that the development team recently implemented, and I wasn't a part of that, so I don't know what the approach was.
So I can speak to that. It's not necessarily semantic versioning, but it does, as you can see here, include date and ever increasing version numbers. So you will know the 19th build on July 4th from the 18th build, but it's not strictly semantic versioning.
Yeah, and there's always arguments about it. So.
And then another question for you, Jose, is why did you choose Azure specific approach as opposed to Docker-based cloud agnostic method?
I think for us, and it wasn't a decision that I made personally, but I think we've always thought we were going to end up hosting stuff in Azure. And you get a lot of this when you're an Azure customer, when you have, what are they called? Like Office 365 licenses, a lot of this stuff kind of comes free, and there's a lot of like neat integrations, right? So I don't have to create a user in Azure DevOps, right? That person is directly tied to an AD user. So there's just a lot of like cool integration points that kind of come free. And again, I think that's another question that it was actually a decision Dave made probably. If you want to.
Sure. Yeah, and Deepak, I think you'll find and certainly something that we've learned. You pull back the covers on AWS or Google Cloud or Azure, it's all Docker, right? So it is the same thing, and it's just a question of what kind of environment you're comfortable working in.
There you go. These steps here are basically interacting with Sonar Cube. The running of the code. this is a good thing to point out here. The running of the code analysis doesn't actually happen on the virtual machine. It's happening on a Sonar Cube server. And these two steps can actually take quite a while. We're still not 100% sure why. There's a ton of variance in that, something we're researching. But I kind of want to point out that analysis is actually happening. Like my understanding is the heavy lifting is actually happening on the Sonar Cube server, and it's storing like a lot more details about the analysis on that server as well. And then the last thing is we tell it what to package up and get ready, and basically what's our artifact from this build pipeline. For us, the artifact is a zip file. For most of our builds, that isn't always the case. It can be more complicated than that because not everything can be deployed just from a zip folder. There's some Python projects that we've created recently that are a little bit more complicated, and they need a little bit more massaging. But again, I'm just trying to demystify it for you. Like it's really that simple, right? We're just moving stuff around on a computer, or I guess a server image, and packaging up what we need for the code, what we need so that we can push it up to Azure. And then our release process is very simple for the most part, right? Like we define our stages, we define which artifact we're gonna deploy to these stages, and then I guess a couple things to point out. And the reason why we use the UI based approach is we can add approvers on these different stages. So, sorry, I'm not sure. Oh, it's over here. Yeah. No. Okay. Sorry, I might be in the wrong pipeline, but you can
test.
Am I? Okay.
On the test one, we have the approver.
I see. Yeah. So this is like an example of we were able to add a user group. You could actually, and then I mentioned before, it was like tightly integrated to AD. You can actually add an Active Directory user group as an approver here as well. So you could it does pull in from AD for this stuff. It's pretty neat. But we like this approach because we can push the development all day, and then someone on, maybe like a senior person on the team or someone who's on call or whatever can go in and push the test for overnight testing. And then it never touches stage, which is like a demo environment or either of our production regions, unless someone like Mike or myself or Dave go in and push the button to okay it. I don't think I have anything else except if anyone has questions. I kind of ran through it and just trying to give you a good sense of our strategy and sort of introducing everyone to DevOps generally.
And I think there's a question that Dave answered. Dave, you want to go over the answer real quick?
Sure. Yeah. So we actually do the configurations on the app services themselves, and so our prod configurations are static, and we maintain them in the portal. So it's not part of our deployment. Depending on the code that arrives at whatever environment has already the correct configs.
And then there's a question for Jose or Dave. Do you use the environments portion of Azure DevOps at all?
I actually don't. I've been using Azure DevOps and VSTS before that since they came out, and I've never had a valid use case for it. And they've actually started hiding it in some of the newer projects that you create. So unfortunately, I don't have a great use case for that feature. Yeah, and if there are no more questions, I believe Dave's going to poke around in Azure and show us some cool stuff there.
Yeah, thanks, Jose. Mike, do you want to just share? I tell you what, I'll just share that one slide.
Okay.
If I can figure out how to do that. So can everybody see the Azure slide?
Yep.
So what this slide purports to do is to kind of tie up. We've done all the creation, we've done all the building, the testing, and the deployment, and what's next. And so why do we like Azure, and what does it bring to the table for us? Because To this point, we're not done, right? We now have to put the app out there, and it has to be accessible to users, and we have to deal with the risks and threats that are inherent in that deployment. So I've just kind of outlined a few of the key things that we feel are super valuable adds in terms of the Azure environment, and those are that obviously we're using Azure to host our applications, and by doing that, there's built-in defense and protection to that. Part of that is based on the way we do our development, right? So we are focused, I think I mentioned earlier, security-centric development. So the way that we develop software starts at the code level, and then we use a variety of tools, and Jose kind of demonstrated some of those. So Sonar Cube and the testing, but we also use third-party pen tests and third-party software to do dynamic application testing. So we just give it a URL, and it goes out and it kind of crawls the site and looks for issues, and then reports that back to things that can be put into a backlog and addressed. The key component, and I'll show this shortly, is the web application firewall concept that's built into Azure. There's actually a number of ways you can do that, but it's something that you get for free just by being in Azure, and so that's certainly a valuable thing for us. The other things we get are scale, right? You're gonna build an app based on some notion of what the load is going to be on that, and then that load is going to change, right? And how do you react to that? And we'll talk about the two different methods: the scaling up, which means just take the computer you're on and put more memory in it and amp up the processor, or you can scale out, and you can take a bunch of the same computers and just kind of infinitely spread them out wide to handle that load. Next up is redundancy. Obviously, these are computers. I'm sure everybody in this presentation has had something go wrong with a computer or a program, and how do we deal with that? And we'll kind of talk about that here in a minute. So, without further ado, I am going to switch over. Watch me log in. So, Can everybody see Front Door Designer?
Yes.
Did I lose any? Okay. I mentioned a number of different ways that technologies, I'll say, that Microsoft has available in Azure. Front Door is just one of them. And it's the one that best fit our needs. And so what it does is, it's Microsoft's global network and edge system that provides scope and capacity, and it also provides accessibility. So anywhere in the world, although we're primarily only interested in the United States for our applications, people can get to our apps. And when the endpoint that they last went to is down, they can still get there because of the way Front Door works. And so the main components of Front Door are the front-end domains, the back-end pools, and the routing rules. And I'm going to go through them. They're a little bit out of order. I'll start off with the front-end domains. And so, we have a DNS provider where we map, for example, the api.kalderos.com, which is the example I'm going to use. We map that name to an address, and that address is supported by this Azure Front Door in the case of api.kalderos.com. I'll just show you really quickly the kinds of things that you can configure on that. So obviously we want a custom domain, and we want it to be HTTPS, we want it to be 1.2, and we want to use our own certificate, so rather than a Microsoft provided certificate. So the way we store those certificates in Key Vault, I think Jose might have shared with you that's a secure way of storing both secrets, username, password, all sorts of things, and specifically HTTPS certificates. And then lastly is this web application firewall, which we've enabled, and we've created a policy, and I'll show you a little bit about policy here in a minute. But it's essentially a series of rules. What do we want? What do we want to turn on? What do we want the firewall to check traffic for? And we can ignore some things, and we can do a variety of things. We can either, log those things, or we can absolutely reject them. And then session affinity, we're huge on stateless services, so we don't do session affinity. We don't want to force somebody to have to come back to the same server because there's some session open and waiting for them. All of our stuff is stateless, so any front end request can go to any back end endpoint. I'm going to quick a minute jump it over to that firewall policy. And just and give you a little bit of detail. And I just brought up this screen. So this is just an example of the list of things that you get out of the box. And these are the managed rules, so the standard rules. And you can add your own rules, and it's quite a number of things to be protected with. So it's actually pretty cool. And then the other cool thing is that you can come in here and you can turn them all on, and then find out that you can't get to your site. And so that's a little bit problematic because you've got the default is block. So typically what happens when we set these firewall policies up is we'll turn things on as log, and then actually go into the log and see that, yes, this request would have been rejected because it looked like a SQL authentication bypass attempt. And then we can turn that thing off, or we can just leave it on as logged. I don't think we have anything that's just disabled, but you can. It's kind of an iterative process where you lock all the doors. You go out and you find that too many doors got locked, and then you can kind of back it off to your level of security. And so, like I said, you can do these rules. You can create custom rules, and you can do a lot of pretty cool things with that kind of firewall policy. I'm going to skip over to routing rules because logically it makes sense to me. So now we've hit this api.kalderos.com. Like, how are we going to get to the boxes that are responding to this request? And that's by the routing rules that you create. And I'm just going to go to the one that I know is connected to it. So this API-HTTPS, and I'll say here that it's a little bit annoying because I think in most regular, like if you're familiar with IIS, or if you're familiar with just a straight up app service, you can tell it not to always redirect from HTTP to HTTPS, and we found that with Front Door you have to be explicit about that. So if a request came into HTTP API-Kalderos.com, it would hit this endpoint, which is gonna redirect to this endpoint. And our routing rules are really fairly simple. We do all of our routing at the service level based on paths. So everything is going to hit this path and get sent to the right backend. Where is it? Oh, sorry. So yeah, so it's going to go from API Kalderos to API HTTPS, which is supported by a backend pool called DDM API Clustered. There's not much that's interesting here other than, we've already set this HTTPS only. We don't do any rewriting, and keeping with our stateless operations, we don't do any caching either. So the request is going to get here. It's going to say, oh, in order to get this request responded to, I'm going to go to this backend pool, which is where the machines are defined. And that's this one. So this backend pool is composed of two sites, two app services, I should say, and they're geographically separated. That's something that we chose to do, right? We want one in the East region, and I think this might be North Central. I can't remember where exactly it is, but the key is that they're in different places. So Azure gives you that. They not only give you redundancy within a data center, they also give you redundancy across data centers. So something pretty bad has to happen for our apps to go down because more than one place in the United States has to have some kind of specific outage or bad outage, I should say. And so we do the back-end waiting. It's just a 50-50 load balancer, so it's round robin. And the round robin decisions are made based on health. So we just do a head request, which is just the headers for a request that we make against api.kalderos.com, rather than returning that response, the system just returns the headers for that. And so the implication is if the headers come back, then the site is up. And then the load balancing, and sorry, we do this based on 30-second intervals. So every 30 seconds, we're doing that to make sure that the endpoint is up. And if east is not up, it goes to just API, and the opposite is true. And so that really is the front door. There's a lot of cool magic that you can do in there, but that's the important stuff. And then I'm going to jump over quickly to one of these endpoints. So now we're actually talking about a specific app service in Azure. And so this is where the road from Jose ends, right? The code got deployed to this app service, and I've drilled down to these scaling options. So the code is here, it's running. This is where you can essentially, this is where you do your scaling up, right? So if 1.75 gigs is not enough, you can bump it up to 3.5. If an A series compute is not enough, you can bump it up to DB2. And there's plenty of documentation about how those are different. And you can, through testing and through estimation, decide what's the service, what kind of box do you want to deploy your stuff on. And I know if you've dealt with making those decisions in-house in self-hosted systems, it can be a lot of fun, right? Because you don't have to worry about taking a computer down and swapping out memory. You just click a button, which is super exciting. And then there's this list of included features. So as you click through these options, you can see what it is you're getting. So for example, scale is an important thing for us. So in this pricing model, we can get up to 20 instances. We can tell this computer to be one computer, and then based on criteria like load, we can say, no, I want it to be 20 computers, and that can ramp up and ramp down based on actual load. Scale out is that's the next step, right? So the how many nodes we want to have, and we use on this app service custom auto scale. It's not extreme, but we have 2 instances, and we set it up for a maximum of 3. And we scale on a metric, and that metric is that if CPU goes above 70%, we increase the count by 1. The cool thing about that is, say we get to 3 and that's not enough, we just come back here and we increase the limit, or sorry, the maximum to 4, or to whatever, up to that 20 that's available for the hardware that we're on. And that kind of that is the picture of how we do things. And like I said before, that's always been something that you have to make that when you're talking about building software and deploying a new solution, you spend a lot of time, or you spent a lot of time in the old days making those decisions and making purchasing decisions and working closely with the infrastructure folks to make sure that that the third-party load balancer that you bought is working correctly, and that all the firewall rules on the firewall are configured correctly. And it's a much easier thing to do these days, and it's really you can act like a world-class software company relatively easily compared to the old days where it was a lot of money and a lot of implementation and big teams. So I think we can't speak highly enough of Azure, and I know that AWS supplies the same thing, and it's really just a choice of flavor, but we're fairly happy with how it works on Azure.
So we had a question in the chat. I think I can answer it. So the question was, are you using infrastructure as code, or are you managing resources in the portal? I think that's not an easy answer. Like, it's not easy to answer that. It's a little bit of both. For our more established applications, like things that have been iterated a bunch, and we're, you go back to the beginning, we talk about being like a microservices organization. We don't always, like, there's a lot of resources that sometimes it requires a lot of resources to have a fully blown infrastructure as code deployment. So we kind of take it a step at a time, right? So we're constantly like moving things from being managed more manual to being more automated, and moving towards an infrastructure as code. So it's sort of like a work in progress, and I think that's like euphoria for us to have everything infrastructure as code. But at the moment, it's a little bit of a hybrid approach.
Jose is going to bring us there.
That's the plan.
So I think that was the end of our presentation today. Does anybody have any questions they weren't able to ask about any of the topics we covered?
Yeah, well, thanks for having us. Thanks for allowing us to present, and reach out if you have any questions after the fact.